I welcome our first speaker, Mr. Kalva Bhadrayya, founder and director of Swaroop Tech Services Pvt.Ltd, Hyderabad. He is in chemical engineering with a specialized in the area of total quality management, ISO 9000 and 14000, industrial engineering with OR and statistics. Mr. Bhadrayya has wide experience in various fields of multiple disciplinary approach. He has worked as a visiting professor at Pilani and visiting faculty at Management Development Institute Gurgaon. He worked as director for board of Rajasthan Drug and Pharmaceuticals, general manager for Indian Drug and Pharmaceutical, and senior manager technical service at corporate office IDPL. After retirement in 1996, he started the mission on building a quality into the process at the level of research and development functions for pharmaceutical companies. To achieve this objective, he designed a software called SigmaTech to enable scientists to implement QBD, quality by design, with the help of SigmaTech. Mr. Bhadrayya, I request you to start your, by sharing the screen, start your session.
Why QBD is a must for pharma industry?
Can you play it, sir?
Yeah. In pharma industry, the obsolescence of medicine is very fast, relatively. With the result, the companies always work on finding new products and process to compete in the market. This is why R&D has become a must in pharma industry. But unfortunately, many pharma industries follow good old methods of process development by resorting to traditional methods like subjective methods, hit and miss method, trial and error method, O-factor, that is one factor at a time method. These methods will not enable the scientist to achieve the least cost, best quality, and least delivery time, which are the cornerstones of the business organization to compete in the market. The pharma companies incur a cost of non-conforming to the quality to the tune of 25 to 30% of sales turnover as a result of these traditional methods. Since these costs are hidden across various departments, they cannot be seen so easily, and the survey shows that the cost of not conforming to quality are huge. Best observed one in the traditional method was taken as an optimal, but in practice it was not possible to attain consistent results due to the variation that violated the specifications. Tighter specifications for raw materials and operating parameters were imposed to obtain a better result. Even the better results obtained were with increasing costs. In fact, the factors affecting the variation were unpredictable, basically due to OFAC and other conventional methods. When the quality preference came on the scene, then it was intended to build the quality into the process. Then all sort of in-process inspection, statistical control methods, etc. started. Okay, but then what happened? But throughout these stages, focus was more on the inspection only through the different methods. Again, it was forgotten to build the quality into the process. So rejections at incoming materials, in process level, and final product level reduced, but could not be to the desired level of reduction in defects. The quest for quality continued. The quest to quality question whether the given process is capable of giving a defect-free production. Then came another methodology called process measurement and process capability index came into the limelight. On measuring the process capability, we could only know at what level the existing process is running and the level of consistency in the process. But still, the question remained how to improve the process capability for defect-free production. With the application of the SQC and process capability, only the identification of assignable causes and inherent causes could be established. But how to remedy the assignable causes became a problem, particularly at production process. See, in the various methodologies like philosophies started getting implemented like benchmarking, BPR, QC, TQM, TPM, etc., ISO, to eliminate the defects at the source level like men, materials, methods, and machines. Though the improvement has been there substantial at operational level, at production process level, not much dent was observed because of technological issues. Motorola was trying to improve the quality by various methods, but could not reach the Six Sigma level quality. And when they applied DOE statistical design of experimental methods, they could quickly achieve the Six Sigma level, a highest level of quality. Then DOE came into limelight about the benefits of DOE. DOE means design of experimental methods, statistical designs. Because of two, okay. In fact, when the data was submitted by the pharma companies to the regulators, they were asking scientists what happens if we go beyond or below the set points submitted. The scientists were not able to answer to the satisfaction of the regulators. The regulators felt that the dynamics of the process development is not understood, and hence they felt a new approach required for the complete understanding of the process dynamics to develop a robust process with a wide range of parameters where the quality will not suffer. Keeping this in view, ICH, to which USA, Europe, and Japan are members, have formed certain guidelines around 2000 for the process development to mitigate all these difficulties. By adapting to QBD, international market acceptability will be forthcoming and easy to move exports around the countries like USA, Europe, Japan, where our maximum efforts are taking place from India. ICH guidelines for QBD have been adopted as law in several countries, but are only used as a guidelines for the US FDA. The same have been issued by FDA in 2006 production by the Pharmaceuticals. The tools of the QBD for the implementation of ICH are ICH Q8, dealing DOE application, design and development of the robust process. ICH Q9, implementation quality risk analysis. ICH Q10, implementation quality systems and CHMT. ICH deals with the DOE as a tool which requires software for implementation, and it is primary tool scientists to use it in designing and development of a robust process. Robust design methods refer collectively to the different methods of selecting optimal targets for the inputs. Generally, when one thinks reduction in variation, tightening tolerance come to the mind, which is costly affair. But as demonstrated by Dr. Taguchi, variation can also be reduced by careful selection of the targets. Some of the methods of robust design are dual response approach, Taguchi method with S/N ratio, simulation of process models and graphic interface, design space, which is required by for the regulators when you are submitting the Six Sigma approach, measurement of process by process capability index, and applying DOE technique to improve the process. So today I am going to show demonstrate one application of this measurement of the process by process capability index and applying the DOE to improve the process. This is about theoretical background of the QBD. Now we'll go for the application part of it as a case study. Is it visible, Mr.? Hello? Hello? Is it visible?
Yeah, it's visible, sir.
Okay. This is introduction about this process measurement and process improvement. A case study with the application of these techniques, process measurement and improvement in process industry is very useful to the process engineers and production engineers to understand the concept. How to define, measure the process, analyze and improve and control. It's called DMAT. in process industry is shared with a case study presentation. Define. One of the penultimate stage in a drug manufacturing process called pyramidal, the yield was too low, around 40% against an expected yield of 60%. Since in the process the isomers are formed, the desired isomer cannot be more than 60%. There is a huge gap between 40% achieved and 60% expected. The process chemists have been telling that all the operating parameters like temperature, pH, time, and etc. have been standardized, and as per the SOP, standard operating system, they have been producing it. Even then, the variation was too high. This became a bottleneck for the capacity. It was all the more essential to improve the output measure. To demand the process measurement of the existing process, an exercise was performed by collecting the data output from the batch sheets of the process and was measured. Okay. See, the process capability of the existing process. The average was 40.528 and upper specification was achieved only 43 and standard deviation 1.8060. Now the CPK, process capability index, is, as per this formula, it is just about 0.457, which is near 2 sigma level, and corresponding COPQ, cost of poor quality, is 25 to 30%. This is a too costly affair because this is very too quality level. The quality inbuilt was not at all sufficient, That's why mostly, since CPK is less than 1.33, it infers that it is not possible to achieve the targeted yield output in the existing process. Hence, it requires to improve the process. Identification of the input variables for the process. On proper analysis, the input materials ratios were formed, grouped into 3 mole ratios. One is M1, mole ratio of beta ethoxypropyl to sodium. Then M2, number of moles of ethyl formate, and M3, acetamidine hydrochloride to DMS, as a mole ratios. And whereas sodium was kept as 1 mole constant. It is required to conduct a fresh study to conduct the experiment to find out the factors affecting the output. The factors and their levels are given in the table below. Then DOE. Since already OFAT was ruled out for obtaining satisfactory results, DOE method was suggested for investigation by experimentation. This is the most powerful method for investigation of factorial effects. See, this is the Sigma Tech software. You can see, click on problem selection. Then you will find optimization model, screening model. Then ours is a 3 variable model in optimization. So I click on the 3 variables. Then I already stored the data in it. So I am opening this application. Then this is the name of the project and output is written there. Here, name of project and output, it is expressed as a yield in the process industries. Okay. Then save it and click on next. Then this is the variable entry table. This is M1 mole ratio, M2 mole ratio, moles, and M3 mole ratio. Units, numbers, this is low level, this is high level. Okay. Then click on a plan. See, this left side plan is given by the software. Once you enter that input variables, then see what is happening here. 8 experimental permutation combinations have been given by the software. In addition to that, 4 replicate experiments are supposed to be done at the midpoint of these variable levels. And all the parameters also have been given by the software. Accordingly, the experiments were conducted. Their output as yield is recorded in the output column here. Now you will see here, when X1 and X2 are increased here, there was not substantial increase. But when X1 and X2 simultaneously increase to higher level, the output jumped to 56. Okay? This is called positive interaction or synergetic effect of the interactions, which is helping to develop the process, improve the output. Then go for the analysis. This is called statistical analysis. What is happening? We wanted to develop a model y is equal to b0 plus b1 into x1 plus b2 x2 plus b1 in x1 x2 etc. Then for that we need to evaluate the coefficients, that is constants of this b1 b2 etc. All these things have been evaluated by the software, and there SS ratio, this is sum of the squares ratio, it is called in statistics. It is nothing but contribution to the process by each variable and their interactions. Now you can see x1 and x2 both have got positive contribution, just around 5%. But their interaction, x1 and x2 has got a coefficient is 3 times to this, and contribution is 33.5%. This is a very healthy sign, okay, to improve the process. Then x3 coefficient is minus 1.8, and SS is about 49% contribution. So that means higher the mole ratio of x3, lower will be your output, because it is a negatively contributing. So our strategy is to increase the x1 and x2 and reduce the x3 for optimization. And it also has calculated nonlinear effect. Whether nonlinear means the output will go as the variables inputs increase to some extent, then it will come down. It is a curvature effect is there. So the software says the nonlinear is very significant. If it is significant, we are given the guidelines here what to do. Then as per this guidelines, we have to simply click on the composite here. So the composite design, these are the composite design. The moment you click on a composite design, it is asking to conduct 6 more experiments, and their parameters have been given. And as per this, again, the experiments were conducted and outputs are recorded here. You will be surprised to know when we have increased x1 and x2 more higher mole ratio, we have got is 56. Now here, when all these mole ratio are less than those things, previous one, this input quantities are quite less than compared to previous one, still it is giving 56. Because of the nonlinear, this phenomena will be happening. So this is a very good sign. I mean, even with the lower inputs, you will get the higher outputs. Then click on the analysis. Now you have got the quadratic model completely developed here. This is earlier already we have developed up to this. Now x1 square, x2 square, x3 square also have been estimated here. Now full quadratic process model is available, and no more experiments need to be conducted. Okay? And now we go for the simulation to achieve our expected results. In the simulation, what happened? It has completed about 25 simulations. Automatically it does it, and it is given output also here. Response output is given. So it has given the 60% of achieved one also, and others also are given. So to understand it, basically I have given a graphical interface here. Now you see, this is x3 has got a negative coefficient, so it is kept as a constant at lowest level. And now we have got 5 levels, x1, right from this level to this level, 5 levels are there. And x2 also 5 levels are there. Each graph is for each one level of the x2. Now you can see 1, 2, these two are coming down, so we are not interested. And there is one thing going very steep, these and these two. That is x2 is equal to 1.96 and 2.18 are going to give the same result. X, that is 60%, at x1 is equal to 1.091. But this is what happens only at a single point here. Now we wanted a robust process where even input in variation in the input should not suffer my outputs. Now you see this part of it where x2 is equal to 1.74, it goes slightly up and then remains almost constant parallel to the x-axis. That means even when you are changing input quantities of the x1 void from 1.023 to 1.091, your output remains almost constant, 57 plus. Okay, this is called robust process parameters. That means even there are changes here in this input material, your quality will not suffer. And this is called robust process parameters, which will give you 57%. Where again the 43 which was obtained in the plant, now this is, and it has been confirmed and again by the experimentation in the lab and implemented in the plant. Okay. Now we are again confirming whether robustness is achieved or not mathematically. Okay. So by the for that we have calculated the CPK. CPK has come to 1.85 and which is equivalent to 5.55 corresponding that is sigma level. And CPK highest level is 2. And this 5.55 correspond to about less than 10% of the cost of poor quality, as low as 5% even. So this is how we can measure the process and improve the process as expected. And you can also verify whether we have received the that is what you call robust process or not. So all these methods are available. Okay. So any questions you would like to put it? I try to confine to the 30 minutes time, and still I am leaving some time for the questioning.
Thank you very much for a wonderful session on QBD, Dr. Bhadrayya. And I request a participant, if you have any Q&A, you can post it through Zoom so that we can able to ask. Sir, I have one more query that, so how many variables is the software is going to take, sir?
Oh, it has got up to 23 variables. See, we have got two models. One is the screening models, other one is the optimization. Optimization module can work up to 5 variables presently, okay? And screening modules, it will go up to 23 variables. When you have got, say, about 10 input variables, you don't have to conduct to hundreds and thousands of experiments. You have to conduct only 12 experiments. And it will sort out as per the Pareto's law, what are the significant contributing factors to the process. And that will come out as per the Pareto's law, only 20% of it. So that comes to only 3, 4 or 5, something like that. And that 3 or 4, 5 will go for the optimization, like that. So first we will go screening and then go for optimization if there are too many variables.
Okay.
It will like
okay. There is one more question. So, which organization is Sigma Tech providing software already, and what is the success rate by using the software, sir?
See, this we have been applying to, given to many leading organizations like Ranbaxy, Freshness Kabi Oncology, which is an Israel company, which is one of the highest bulk drug company, and Freshness Kabi Oncology, it is a German company. Okay. Then we started with Dr. Labs also quite in 2005. Then okay. Aravindo. Then recent one is the NATCO and Suven Life and Newland Labs here in Hyderabad. And Micro Lab also we have then given it this what you call your Bangalore. Okay. So like that, many industry we have covered about 25 institutions and corporate R&Ds.
Okay, great.
Because unless you develop a robust process R&D, the defects are going to continue on the production line. You cannot change in the production line. You have to build the quality only at the R&D level, not at production level.
Okay.
Production level automatically it goes. Once you do it right process at the R&D level.
Okay. Great to know that, sir. And we got one more query from my end, sir. Yeah. Actually, when you have been doing in a software and when you have been doing reality, So is there any percentage of change when you have been doing in software and when you have been doing in really when you have been like in analytical when you have been doing? So what is there any difference or it shows exact results?
No, see what happened when we have given a simulated runs and we have picked up a most optimal one, robust process, that they will again experiment and confirm for the results. Okay. After confirming, it will definitely it should confirm, because there is a measurement of the process model also as an R square we call it, whether it is going to give the correct estimates or not. 99% and above it will give the correct estimates. It is as per that statistical prediction. So they are giving correct results actually. Otherwise, nobody, see, these people would not have come forward to go for this software, isn't it?
Okay.
And they are implementing already.
Okay.
And I have given the consultants also to the Pilani project to the Newland lab just last year, and after coming, once the COVID started, then we were not able to move further again.
On Sigma Tech software, any publications based on the project software?
Yeah, plenty are there. See, applications you will find in various international journals are there. I can share with you about that document also.
Okay, sir.
And particularly, many research scholars also have been taking the advice from me how to use this Sigma Tech, and we have worked with them and submitted the paper, and they have been published in the international journal. And I too have published in some of these things into the different journals.
Okay. So it has been done nationally and internationally. It got published most of the papers.
Yeah.
The help of software. Yeah. So it was. Thank you very much for being a part of our Global Virtual Healthcare Summit, sir. Thanks for your time and giving us a valuable knowledge regarding Sigma Tech software, which can able to support pharma industry to develop a robust process and come up with a solution with even a more number of variables up to 20, and giving the solutions to the industry and making the product come to the market in a quicker way, sir. Thank you very much for your time.
It is basically user-friendly. Sigma Tech is a very user-friendly. The design is like that. As you are carrying the R&D process, it's in the same fashion it is designed.
Okay, sir. Thank you very much, sir.